Alright, hi everyone, welcome to my YouTube channel, City of Electrons. City of Electrons. So in this video, we'll be talking about this right here, okay? Construction of an induction motor. So the thing is this, an induction motor is made up of two parts. This one, stator. So this is stator, okay? And then the rotor, here we have it. Okay, here we have it, the rotor. This is the rotor. Of course, this is inserted into this. Okay, and together they make the induction motor. Okay, so the thing is this, for the stator, it is the stationary part. Of course, you can say, yeah, stationary part. Okay, it has no rotating part. But we'll see later on that it has a rotating field. Okay, not a physical part though. All right, so the stator is the stationary part, this, while the rotor is the rotating part. Here, right here. Okay, this is the rotor. Okay, so the thing is this, for our stator, it carries a three-phase winding and it is fed from a three-phase supply. It really makes sense since the winding is since it's a three-phase winding, it makes sense to have a three-phase supply. Now, it is wound for a definite number of poles, the exact number of poles being determined by requirements of speed. That's the required speed. Okay, you consider that to get the number of poles. Okay, so the greater the number of poles, the lesser the speed, and vice versa. Okay, so when the stator winding is supplied with three-phase current, a magnetic flux is produced, which is of constant magnitude but revolves at synchronous speed ns, and this is the formula for it. Okay, so what we mean by this, a magnetic field or magnetic flux being produced which has a constant magnitude but it revolves. This movement or this rotation of a magnetic flux or field, we will talk more about that here in this topic, sleep. That's in the next video. Okay, but just bear in mind that the stator is stationary, but when it receives the three-phase current or a three-phase supply, it will create or generate a rotating field. Okay, so this rotating field that is being generated that's what will cause our rotor to rotate. Okay, now like I said, we'll talk about that, more about that in sleep. Okay, but just bear in mind what I just said. Okay, so now this formula, you also have to bear this formula in mind. So the rotating field of the stator is known or is denoted as ns, and is the synchronous speed, which is equal to 120 f, which is frequency, divided by the number of poles. Okay, so this revolving magnetic flux induces an EMF in the rotor by mutual induction. So that's what I'm trying to say here. So when our stationary part produces a rotating magnetic field, this will induce an EMF. Okay, so an EMF is induced on this rotor, so that will cause the rotor to of course the rotor will try to catch up with the speed of the magnetic field, or my flux. So yeah, I'll talk more about that when we get to sleep. Okay, I think I've said that. So this is just like a basic idea of how the construction affects the operation, or the construction of an induction motor. This is just a basic idea. Okay, so of course you can go out there on YouTube and then get more videos where you see a more visual construction of the induction motor. This is just a class recap. Okay, so I hope this helps. Really, I hope this helps. So just in form of recap, we said that the construction of an induction motor, that it is made up of two main parts: stator, this, and then the rotor, this. Okay, all right. So yeah, if you have any question or comment, just leave them in the comment section, and then I'll see you in the next video. Like, share, subscribe, and then see you in the next video. We'll talk about sleep and more about this rotating field and ns, and then the rotor and their speed. We'll talk about that in this video, the next video. So thanks for watching and bye for now.